Alright guys, this is the 10-minute tutor and we're back with another video today to discuss the difference between speed and velocity in physics. So I know a lot of people may use the terms interchangeably and thinking that speed and velocity is the same thing, but actually it's different, especially in the world of physics. There's a whole difference to speed and velocity, and just because you have a speed doesn't mean you'll have a velocity, which we'll see later on in the video. So if you've watched the previous video on vectors, you would know that velocity is in fact a vector quantity. So what do we mean when we say a vector quantity? So a vector quantity is something that is made up of a magnitude. So that's really like that. You can think of the magnitude as the amount of force, or something along those lines. And we have the direction, which direction is where you're heading. So for example, when we're talking about velocity, you may use the term 10 meters per second. But we have to state the direction, 10 meters per second north. So the 10 meters per second represents the magnitude component of velocity, and the direction is represented as north in this example. So we just have to know that when we mention velocity, there has to be a mention of its direction. And in order to simply define velocity, there's different definitions, but something I have in my book is that velocity is a vector measurement of the rate and the direction of motion. So velocity measures the displacement over time. So a thing that a lot of people remember velocity as being is the displacement over time, over the difference in time, where x, or delta x, is going to represent the displacement, and delta t is going to represent the change in time. Change in time. Now, when we use the word displacement, it does not mean distance. There's a big difference between saying the distance of something and the displacement of something. And actually, I forgot to say, we use, at least in my book, it's v bar for average velocity. So talking about displacement, we need to understand the difference of delta x. It really does mean, it's not as simple as you may think. It doesn't just mean the distance traveled. So it really means the difference between difference in starting and the difference in where you ended, or your final. So a lot of times delta x is actually represented as difference in your final to difference in your starting position. So this is where you ended to where you started. This is how you find the delta x. So the best way to really explain this is to use an example. Okay, so I have a pretty simple example here that demonstrates velocity pretty well. So picture this is where you are. It's your starting position. And you want to go to your friend's house. Your friend lives over here. But in order to get to his house, you have to walk through the neighborhood some distance to get there. So you got to walk south a little bit, then you got to walk east a little bit, and then you have to walk back north. And say this distance here is 50 meters, and then this is 100 meters, and then this is another 50 meters. And we're going to be using normal compass directions, north, south, east, and west. So in order to calculate the velocity, first we need to know how long this took. What was the time interval? So this would be given, and this was 150 seconds. Now, if you look at this, you may assume that the delta x, or the displacement, I'm just going to draw out a rough sketch here, is going to be, we know it was 50 here, 100 here, and another 50. So you may think that the delta x, or the displacement, would be 200 meters, right? Because you had to travel 200 meters to get from your initial point to your final destination. It was 200 meters. Because you had to go south 50, east 100, and then north 50. But that's actually not correct, because the delta x, remember, represents the difference in your final and your starting point. So we know we started here and we ended up here. We need to know what the difference in that distance is. Well, it's actually 100 meters is your difference. The reason that your delta x is going to equal 100 meters is because it doesn't matter how you got to the path. You see, when we're traveling this direction, it doesn't matter that we went this way some, and then this way some. That really doesn't matter because you started here and we ended here. This distance here is all that matters, and this distance represents 100 meters. That's really all that matters because that is the difference between your final destination and your initial destination. So in order to solve the equation for this, we have to know that it's v bar, which is the average velocity, is going to equal delta x over delta t. And we know that our delta x was 100 meters, and our delta t was 150 seconds. So solving this equation here would give us 0.667 meters per second east. We have to make sure we stayed east because from where we started to where we ended, we headed east 100 meters. So we have to make sure we include the direction and the magnitude here. We just have to make sure that we say it's 0.667 meters per second east because we need to include both the magnitude and the direction, and the direction that we're heading is east because, as you can tell, from where we started to where we ended, we headed east according to the compass. So speed, when we talk about speed, it's a scalar quantity that indicates the rate of motion of distance per time. So in other words, speed is the distance. Keep in mind it's distance, not displacement. Distance over time. Or I'm just going to abbreviate it as delta t, which is difference in time. So when we're talking about scalar quantities, a scalar quantity is a quantity that is only going to be defined by magnitude. We don't need a direction. There's no direction needed. You can fully describe the quantity based off its magnitude. So that's what speed is. So the equation for speed can be represented in a few ways, but the one that I have in my book is V average equals d over t. Actually, delta t. So where d is going to represent the distance traveled, and t is going to represent the time interval. So it's a pretty simple equation, as you can tell. So we don't have to mention direction, like I said. This is really the only equation for that. So going back to the previous example of where we were here, and then your friend's house was here, and we know we traveled 50, 100, and 50. Just put 100, just to remember that. And I'll write 50 here, 50 here. So as you can see here, when we calculate our speed, it's a little bit different as compared to the velocity. So say it also took us 150 seconds. So that's going to equal your delta t. It took us 150 seconds. So according to this equation, when we calculate speed, it's V average is going to equal. Now, instead of being displacement, we're talking about distance. So the pure distance that you traveled between your house and your friend's house was actually going to be 50 plus 100 plus 50. So that's 200 meters. It's not only the difference between your final and your starting, it's actually the amount of distance that you traveled the whole time. So we traveled 200 meters in a span of 150 seconds. So I'll do it on the next page. V average is going to be equal to, we had 200 meters over 150 seconds. So this gives us to be 1.67 meters per second is going to be equivalent to your speed. So as you can tell, it's actually a different quantity here compared to velocity. Our speed is actually higher compared to velocity, whereas the velocity was 0.667 meters per second east. So for speed, we don't have to mention the direction, but for velocity, we have to make sure that we do. And the speed is actually greater here because we're taking into account all of the distance traveled. So this was kind of a really basic overview of speed and velocity, but I hope it made a difference in the way people understand the two. So we look forward to more videos. We'll be talking more topics about this.